My name is Robert French. I'm a applications engineer with GoEngineer. Been doing 3D printing with GoEngineer for about 2 years now. Before that, I did SolidWorks and CAM. So got a pretty diverse background. With only a couple attendees, you guys are feel free to ask questions anytime. I'll field them. I got it open on my screen, so I'll see them. Ask whatever you want. Real open here. Really want to just give you guys as much information as possible. So we're here to talk about the Open Material License from Stratasys, or OpenAM. Oops, sorry, here we go. All right, yeah, so Open Material License. It's currently available on the Fortis 450. There's going to be some more machines added in the future. Stratasys hasn't let us know yet, but definitely going to be expanded to more machines. It's going to require a hardened head upgrade for some of those more complicated materials, some of those more abrasive materials that could potentially damage some of the softer, simpler components of just a normal head. It does require an additional license, whether that's purchased annual or perpetual. And there's a new software involved with it as well called OpenAM. So with this new open material license where we're really expanding what materials we can use on existing Stratasys machines, Stratasys has kind of classified the materials into some different groups. We have the preferred materials, which are materials we've ordered from Stratasys, since day one. It's their preferred materials. They manufacture them, they certify them. You're buying the machine and the material all from one company, and they guarantee it to work. But we now have validated materials as well. These are materials made by third-party companies, but Stratasys really liked them, saw great potential in them, and has went ahead and done the due diligence of very extensively testing these materials, making sure they will work on their machine, they can certify the results just like their preferred materials. Some of the popular ones here are Kimya, which is a polycarbonate, and the -FR means fire resistant. It's a pretty cool material. We actually have a customer that we're talking with right now that makes firefighting equipment. So really cool application there, and hope it works out for them. Victrix is a Antero or Ultim-like material. It's got all the strength, temperature, or heat resistance, and kind of FST, flame smoke toxicity, chemical resistance, but it can use a soluble support. So some of those really high-end materials were great, but shapes kind of got limited. What geometry we could print was limited, and because we had to worry about manually removing support. But now that we can soluble support with this high-end material, it really expands, what types of geometries we can experiment with. And then HIPS is one I just mentioned because it's one I've been experimenting with. It's high impact polystyrene. Just a cool material, really strong against impact forces, obviously, and just one that I've been experimenting with personally. Lastly is the open source, right? Open material, where's the open source, right? So we can buy these materials from anywhere, but it's up to us. Stratasys isn't going to provide any, real back-end work to tune this. There's obviously guides and different help files and things like that that'll help you tune and test yourself, but it's the onus is really on the end user, the end customer, to make sure this material is going to work and be reliable. So like I said, there's resources out there. It is on you to test those open source materials, but there is a lot of information out there already from Stratasys. You can see all these different PDF guides. In fact, I've been talking with one of their lead engineers on the open material license, where he's currently in the process of creating additional guides, for a few other aspects that, people will need help on, and I needed help on, right? So I reached out to him and he asked for feedback on the guide. So a lot of effort being put into helping the customer help themselves. Right, GoEngineer AEs. Myself, a few others have open material licenses at GoEngineer, and I'm experimenting with it every week, trying different materials, trying different settings, just trying to jump in, get my feet wet, and learn as much as I can to help you, the customers. And lastly, our YouTube, myself, I've created a few videos on this topic already, including the software that's required, the OpenAM software. Coworker of ours, Joseph Miller, has also created a lot of great guides for creating the canisters, loading them, and so on. So the OpenAM software, just a kind of a quick review, just a quick walkthrough. I don't plan to jump into the software, but if anybody has questions that require me to, I'm more than happy to, or if you guys want to see a little bit more hands-on approach to it. But the OpenAM software, very simple, a lot like GrabCAD, where we're just kind of going down a column in GrabCAD's case on the right side, but in this case in OpenAM, we're just kind of going down these few buttons on the left-hand side, starting with the profiles page. Creating a new profile. You can see the one I've highlighted, I've called Glow ABS. I found a pretty cool glow-in-the-dark ABS material that hey, it looked like fun. Let's give it a shot. Why not? See if we can make it work. So I create this profile and kind of choose what tips, what support, how do I plan to run this material? Then I jump over to the tuning page for this material. And this is where we get into the nitty gritty. This is where most of your legwork, most of your effort will probably be dedicated in this software, is tweaking all these little parameters, all these little settings to make sure the material runs correctly. So for instance, on this Glow ABS, a lot of these third-party ABSs are running on not industrial machines like a Fortis 450, right, that has sealed build chamber, heated build chamber, heated build bed, right? A lot more sophistication going on. A lot of these materials want to run at a lower temperature on a hobby level printer or a prosumer printer. But our Fortis 450 is a lot more capable than that, wants to run it at a higher temperature. So one of the first things I did is jump in here and bump down that extruder temperature in the first column there. Try to get a little closer to some of these, once again, hobby level printer, what they expect. And notice it's a range. I can't just type in whatever number I want. So there is a little bit of guidance in this software. It's not just wild, wild west, set the number wherever you want. It's going to keep you within a pretty, good realm of, we expect this to be about how this material should run. And I've barely scratched the surface here in this screenshot. You can see at the bottom of it, it says display level 1. If I bump that up to 2 or 3, it starts to unlock more and more options. So if it's pretty known material that's run on a Fortis 450 before, like ABS, I'm not too worried about jumping into very nitty-gritty details. I can stay display level 1, just change some of the more obvious parameters like temperature. Once we do that tuning of that material, we can jump over to this sets page. A set is, I'll have a tuning package for ABS, a tuning package for Ultim, a tuning package for HIPS, a tuning package for every other material that I plan to eventually package together and send over as a firmware update to my Fortis 450, right? I can't upload more than one setting for each material. I can't have 2 different settings for ABS, right? Because the Fortis 450 only knows how to print the ABS one way, how you've uploaded it. So I can't have, a package can't contain more than one material set, right? But I can do one for ABS, ASA, PC, whatever it might be, just no duplicates. So I can bundle a bunch of these different tuned materials into a set, and eventually create a package out of that. And that package is that firmware package that I'm going to send over to my machine. You can see here on the packages page, I've linked to my Fortis 450. And I have a couple options as well for upgrading GrabCAD print, right? There might be some different material or different setting that I've tweaked that GrabCAD print also needs to be updated and kind of be on the same page with my machine at the same time. So everything's talking together and communicating correctly, and I'm going to get the expected results. Right, so I push the package to the machine, kind of like adding a material license. Just a quick screenshot there showing kind of how that's located and shown on the 450 touch screen. You can see that middle screenshot listing a lot of those different materials. You can see the Kimya in there. Anytime you see a material like ABS-G, ASA-G, PA12, the nylon-G, that all stands for generic. That's that kind of custom material that you've purchased, that open source material. So when we buy these custom materials, Fortis 450 canisters are a pretty specific design and need to be loaded a pretty specific way, right? They're created to load into the machine. So how do I take this random spool, this, off the internet from whoever spool that's going to be different every time? I need to make that work inside of a Fortis 450 canister. So you can buy empty canisters, or you can reuse existing ones. For my first time, I decided to buy a empty canister just to kind of see what I'm getting. What do I expect? Is there anything different from it to a existing or used 450 canister? And it didn't really seem like it. It seems like anyone would be valid. We get some aluminum tape. If you've used a 450 canister before, it's got that very shiny tape to kind of seal and keep moisture out. I printed some adapters, right? So you could use an existing spool off of a 450 that's already loaded in a purchased canister, but Stratasys has actually started to kind of warn against that because you can get cross winding and kind of jam the canister. So printing adapters seems to kind of be the more preferred approach right now. Get an EEPROM chip. So that's that small baggie on the right side of the screenshot here. See if I can remember exactly. It's electronically erasable, programmable, read-only microchip, right? And that's just the type of chip that makes sense for this application. It's basically when you're loading this canister in the machine, these EEPROM chips that are on every canister are read by the machine to know what is loaded, make sure everything's matching and communicating correctly, everything's on the same page, including back to GrabCAD print. You can buy these chips for all the different material classes: ABS, PA12, PA12 carbon fiber, ASA, whatever it might be. Some desiccant packets. These are in every canister, just making sure we're keeping moisture out. You can buy packs of these separately or potentially reuse existing ones, though they do start to lose effectiveness over time. And then, of course, you need your custom material that you've purchased. So creating the adapters is pretty straightforward. There's really only 2 dimensions or so you need. You can see I'm measuring kind of the thickness or width of my custom material reel, and also the inner diameter here. And once you have these 2 values, it'd be very easy, and if you're doing open materials a lot, to kind of create a SolidWorks or whatever CAD system you're using, kind of a template file, right? And you can see how I've labeled some of my dimensions here, where I say always, like these are the dimensions that should always be present. And this is actually the place where I was, trying to do a little bit myself, and actually reached out to Stratasys and learned that they're developing a guide for this process. And, I was giving them some feedback about what I saw, and they obviously gave me some values here that make sense and seem to work a lot of the time, and labeled some of my different dimensions here to let me know, real quickly, once I have those 2 dimensions, can come in here, plug them into the 2 dimensions that need adjustment, and going to get working adapters every time. So assembling the canisters was pretty easy. Once I had my adapters printed, you can see them there in the top left. They slide really easily over to these hubs inside of the canister. I installed my EEPROM chip. It's just one quick Phillips head screw, real quick and easy. Threaded my material through this little plastic kind of guide piece that's inside all canisters. Loaded it up with desiccants. So the existing reels inside of a preferred Stratasys canister, preferred material, there's big slots where you could insert these different desiccant packets. So That might be something else you could potentially print to hold in place or potentially tape them in there. I chose to just kind of pile them at the bottom of my canister, but that does present its own risk, which is you just don't want them to get in the way of the wire and get pinched and prevent your reel from unwinding, correctly. But I placed them at the bottom, sealed it. I knew where I'd put them, and so I held my canister kind of upright, made sure they wouldn't get caught or pinched. And uh, once the canister's loaded, they're not going anywhere, and we're good to go. And then obviously I sealed the whole thing with some aluminum tape and off to the machine. And once again, not only is Stratasys developing a guide for this, Joseph Miller, my coworker I spoke of earlier, has already created a YouTube video on this. It's very straightforward, and he does a great job, explains everything. Take your time when doing this. Once again, like with my desiccant packets, I want to make sure they don't get pinched. These metal canister housings are, sheet metal, and I did get a small cut, so maybe wearing gloves is advised, or just be sure not to grab it where the lid is or where the sheet metal kind of ends at a bend. You can use the old materials and reuse the not existing chips on already purchased canisters, but chips that are, once I use this ABS generic chip that I use for this glow in the dark material and I buy another generic ABS, I could reuse that chip again. Yeah, be careful of your desiccant placement, as I said. Yeah, and respooling not advised. So the few things I learned in my first attempts at using an open material. So another big note is, we're going to run a calibration part after we've loaded these materials, and I had never used this material before, and when I ran the calibration, it had started, and I kind of walked away from the machine to do another task, and I was thinking to myself, oh wait, I didn't send my tuning package to the machine yet, right? So my ABS is running at this kind of normal ABS, what the Fortis 450 normally runs an ABS at. I said, oh, I don't know if I'm going to run it that hot. I'm pretty sure I'm going to want to cool that down, but I run my calibration part already. Might be better to first send your tuning package, and you can see at the top there, if you know the material. And I had a pretty good expectation. I kind of knew where I was going to run this, so it might have been better to run the calibration after sending the tuning package. And the left-hand side is the non-tuned calibration part. And if you look closely at some of the letters and kind of zigzags around the back and forth around the perimeter of the part, it's kind of squashed the material and it's kind of runny. And that's because I had set the temperature or left the temperature too high, left it at its normal temperature. But after I'd sent the tuning package over and reran the calibration part, it seemed a lot smoother. I wasn't kind of dripping and pooling and kind of splashing all over the place with my calibration part. So just another thing I learned. So pretty cool results at the end of the day. The material quality itself looked really good. Just looking close in at the print, they didn't have any, hairs anywhere or spider webs or anything like that. You look closely at the picture in the top right, you can see it's very uniform, very smooth on the side of the parts. The vertical faces felt very smooth and consistent. The bottom left picture, this glow in the dark material is pretty good. You have to kind of, like most glow in the dark stuff, it has to be exposed to light for a certain amount of time. So that bottom left picture is, putting it up kind of on top of my 450 actually, which is right under a light inside of our print room, and left it exposed for 5 minutes. And that's just a normal exposure picture I took. The bottom right picture is actually kind of a nighttime shot, right? The exposure time is a little bit bigger, but can really see that glow effect is actually pretty prominent and pretty cool. Tori is just the name of my niece, and thought I might try printing, a part for her and be cool decoration for her room or something. But yeah, pretty cool results. I was pretty happy with it. Pretty fun material. So just a couple thoughts on OpenAM. I know I've expressed several of them already, but I was pretty intimidated by it at first. It seemed like having access to any material you find, you never know exactly what to expect. You might order ABS from one company one day and ABS from a different company another day and not get the same results, right? But the Fortis 450 is a very dependable, very reliable machine. So the results were pretty consistent. On that HIPS material, for instance, I was varying the temperature quite a bit, trying to see if I could, force a little bit of an issue, see if I could make some bad results happen. And it was actually pretty challenging to do that. So it was nice to know that it's not hard to jump in and get started and pretty quickly learn, what's important. But it still isn't as dependable as a validated or preferred material. There's still tuning that needs to be required. I'm far from optimizing my glow in the dark ABS, for instance. I haven't done any kind of strength testing or, some of the more required characteristics of a material. It takes lots of specimens to be printed, lots of testing to be done to really know you're achieving similar results, and it'll be a worthwhile. The material will satisfy your design requirements. And it's not necessarily cheaper either. I mean, the annual and perpetual license have, associated costs with them, and there's a lot of time investment for trying to make these materials work. So it's not something that should be embarked on lightly. And once again, the difficult to master, I kind of already spoke to that, but I've only printed, 5 parts out of the glow in the dark ABS, and I haven't put any of them under any, big test of strength or accuracy or anything like that. And that certainly can take a long time to fine tune. I've only tweaked maybe 1 or 2% of the settings that are available in the OpenAM software. There's a ton more settings and a lot more tweaking that could be done. And once again, haven't put them through the rigorous engineering requirements for what a lot of people expect out of a Stratasys preferred material. And that's it. End of the webinar here. I have if anybody has questions, you're more than welcome to type them in or take down my email address here. And if anybody wants to see me jump into the software to mess around and kind of see it live, I'm happy to do that too. But yeah, that's it. My name was Robert French. Thanks for watching. Thanks for attending.